Okay, students, welcome. It is me, Mr. Campbell, here now at Jefferson High School in the background. And if you look here, guys, we are on day two of our newest unit, which is our Earth Change and Stability unit. Now, if you look here, we have our Go Blue, so you need to go ahead and write that down. I want to let you guys know with our video lessons, we will be taking notes in a notebook. Right? We will have to record this stuff, and you will be graded on it every other week for a notebook check grade. I will ask for 2 random pages in your notebook, and you will take pictures of them and send them to me. So make sure you're recording the Go Blues, make sure you're recording the video questions, make sure you're recording the notes. I will try to keep video lessons to the best of my ability, 15 minutes, and not much longer than that. So I will try to rush through things. You need to pause and make sure you stay up to speed and schedule with things. So as we can see here, again, this will be a lot faster than a regular lesson where there's discussion with students in a classroom, right? So again, video lesson, it's all for your convenience because I know a lot of you can't log in at the same time. We see here, number 1, is evolution random or purposeful? Explain. Number 2, what can location tell us about evolution? And then 3, what body structures do we no longer use as a result of evolution, right? Kind of ties into the things we talked about last time. Keep in mind, within our Files tab on Canvas, you will see this fill-in-the-blank sheet. You can print it out, or you can write the notes from scratch from the presentation. It is totally up to you. No problem at all. Again, it's under Canvas. You go to Files tab, and then you go to the Unit 1 tab, and then you will go to, I believe, where it says Notes, and you'll find what is Evolution Notes. You can print that out. Just as a reminder, again, ignore this at the bottom. I've got to update that next time. The syllabus signature is going to be due no later than next Friday. You've got the syllabus quiz that I need you to complete as soon as possible this week as well, if you haven't already. And I think most of you have. And we also have the new Facebook activity. Ignore the bell there. We have the new Facebook activity that was done in class. It's super easy. All you guys have to do is just tell me about yourself. It was an icebreaker activity so we could get to know each other. Kind of tell me about what your favorite music, kind of your hobbies, your favorite topics in earth space science, as well as your future goals for career and more schooling. What's maybe your dream job? But let's go ahead. Let's get to answering these questions. Again, it's going to be our video lesson, going to be a lot faster than a regular lesson. Is evolution random or purposeful? Okay, we'll get back to those videos later. But for number 1, it is purposeful. Okay, things don't just evolve randomly. And again, make sure you write these answers in your notebook below your Go Blue question. So we look back here. We're on page 4 now. Again, page 1 is table of contents from the other day. Page 2 is the Go Blue and the video questions from the last video lesson. Page 3 is the fill in the blank sheet, is your notes sheet. And page 4 is now going to be this Go Blue. Okay. I know you can't really see that. I'm in a small screen, but kind of get an idea. Your notebooks will be graded. You are being graded for your notes, okay? But yeah, evolution is purposeful, okay? Because nature is selecting the traits. Nature decides what lives and gets to reproduce. Okay, number 2, what is survival of the fittest and what drives it? Provide an example. Well, survival of the fittest, guys, is simply put, oh, no, that's from the video, my bad. What can location tell us about evolution? Well, different locations cause different evolutions. If something's near water, it's going to evolve aquatic traits. If something's over land, it's going to evolve terrestrial traits. Ignore the bell there. Okay, so for example, and you don't necessarily need to write this down. You can if you want. Focus on the yellow here. Prehistoric dogs that were on land evolved into wolves, and those that were near water, a lot of them, some of them evolved actually into dolphins and whales. We'll get into that at a later time. And actually, let me go ahead and I'll show you that in a little bit. Let's focus before we answer number 3. What body structures do we no longer use as a result of evolution? So we have structures in our bodies that we literally don't use because we've evolved, right? and they're from our ancestors. Let's go ahead. This was our third video question from the other day that we never got to. What are 5 body parts that are now useless to us that have been left over from evolution? So let's go to this video. We're not going to watch all of it, but let's take a look here. Again, it's your responsibility to watch the majority of it and see some of those body structures.
Proof of evolution. But some parts have grown unnecessary over time. Here are 5 useless body parts left over from evolution. 1. Tailbone. Tails provided balance and mobility for our 4-legged ancestors. As we learned to walk upright, the tail shrank. We still show evidence of a tail early in the womb. At birth, all that's left is a pointy tip at the end of our spine. 2. Wisdom teeth. Wisdom teeth were not a problem until we started farming. 12,000 years ago, we started eating more soft, cooked grains. Softer foods don't work the jaw muscles as much as hard, raw foods. This has led to smaller jaws and less room for teeth.
All right, so again, you need to watch all of that on your own to get all 5 of them, but I'm going to provide you at least 4 of them from our Go Blue. So let's take a look from the Go Blue today, what some of those were. We heard tailbones, okay? We heard wisdom teeth, but also things to include are the appendix, an organ that we no longer use anymore, and the erector pili, also known as goosebumps. So again, no longer have tails, evolved from creatures with tails. We no longer really use it except for like sitting on it. The appendix is actually an organ that is supposed to process like plants and better digest like complex plants. We're omnivorous, so we don't necessarily even use it to process the vegetables we eat in our diet. It can sit there, and oftentimes we remove it, and it literally has no negative impact on our bodies. Wisdom teeth, right? Our jaws used to be a lot bigger, so for eating larger things or animals, things like that, we need those jaws to break that food. Now we don't, because we made materials and cut food up that way. And then erector pili, again, those are the muscles in your hair follicles to stand your hairs up. Back in the day, when we were more hairy as cavemen, when animals feel threatened, when a cat feels threatened, it sticks its hair out to look larger. So did we do that to predators, to say like saber-toothed cats, we would raise our hairs to look more menacing. Okay, so here's a little example of, again, dolphins evolving from those prehistoric dogs. Can we see from the first stage to a little an intermediate stage to some of those final stages, right? So again, you kind of see how those creatures are very dog-like. Dolphins are very friendly, kind of like dogs are, right? We can see the wisdom teeth here, again, oftentimes kind of just under the jaw because they literally cannot fit in the smaller jaw that we have now. We have the appendix, again, often removed, just a little piece of the large intestine there, tailbone and erector pili. All right, so go ahead, update your table of contents. Again, this is on page 1 of your notebooks. You should add page 4, evolution structures. Again, page 4, evolution structures. Okay, evolution structures. All right, so you guys should have moved on. Let's go ahead and I'm going to see here. Did I go over evolution structures? No. Okay, I'm showing question answers, and I'm upset about that. All right, so let's see. Did I go over these? I think I went over these another day. Yeah, so I'm going to go over. We'll get to those tomorrow. And I feel like we're going a little faster than the in-person class as of right now from all my e-learners. So let's go ahead. Let's just for today finish up the what is evolution notes. We left off on the evidence for evolution, right? We talked about comparing anatomy, the body structures, embryos, fossil record, DNA, species, how species are spread out, biogeography, and all of that. So let's move on to finish this up for the day. What do we notice about the animal skeletons? So you guys would all turn and talk. We would discuss it. What do we see here? I have a bat wing, I have a whale fin, I have a cat leg, and I have a human arm. So what do we notice are the differences? Or what are this? Even though in person these all look completely different, right? What's the similarity that shows they're related? It's the bones. They all the same number and the same bones, even though the bones have evolved to different shapes and sizes. Okay, we call these homologous structures. We'll define that later tomorrow. Okay, so whales descended from land animals. I showed you the dogs earlier. A human arm equals a cat leg, bat wing, whale fin. So again, there's structures that are different, but that share a common ancestor. They share a common ancestor. So different structures, different structure, common ancestor. Okay. Our first practice question again. I think I showed this the other day. Evolution is a random process directed by natural selection. A, true, or B, false? The answer is going to be B, false. It's not random. Not random because nature selects. Okay? Evolution, okay, and then that was for like practice. Is it selective? It'd be true, right? Okay, so embryology, embryos. An embryo is the earliest stage of an organism developing. I've got a fish embryo. I got an amphibian embryo, reptile embryo, bird embryo, mammal embryo. What do we notice here? What trend? They all look the exact same in their earliest stages. Okay, if I got an insect embryo, it wouldn't look anything like this. So it shows us that these creatures are more related to others. If I got a jellyfish embryo, it would look completely different. Okay, so yeah, no need to write this down. Write this down, right? Comparative anatomy. Okay, that should have been written down already. Okay, questions, don't need to write those down. Don't write this down. Do write this down. Okay, embryology. So the study of embryos, and we see here that dolphins, human, and other embryos look extremely similar when at the same stage, what I just talked about. In the future, I'm just going to highlight in yellow what you need to write down. We'll do that. I didn't want it to confuse my in-person learners, but we'll just go from there. Okay, we already did the video. We're good on that. Vestigial structures, structures we no longer use. And in our notes, there are intermediate fossils between land animals and whales, right? And intermediate fossils show the migration of the nose from the snout to the top of the head, right? So dogs have their nostrils up front, but we see over time whales and dolphins from those dogs evolved with their nostrils, we know, at the top. We know as the blowhole, right? Why would that be the case? Why would they need their nostrils on the top of their head? Because whales and dolphins breathe air, and it's easier for them to breathe air if it's on top when they go to the surface of the water. Again, vestigial structures. Well, they still use that. It's not a vestigial structure, but it's kind of an example of evolution. Now, an example of a vestigial structure we can see here in this picture is the whale leg bones. Yes, whales actually have leg bones that they no longer use. That is a giveaway for them being related to mammals, being related to land-dwelling creatures. Okay, next we have DNA comparison. We talked about that the other day. Again, whales are more related to us in DNA than they are fish, than they are sharks, okay? Closely related to hippopotamus compared to a shark because they have a common ancestor. They are mammals, okay? I'm giving away questions, all right? And what I'm gonna do, okay, we're almost done. We're almost done. All right, and the last thing of the day, guys, species distribution. Okay, if we get way ahead of the on-site class, again, we'll take a day off from the video lesson. We'll just see, and I'll have another activity. We'll just take a look and see. Species distribution, again, how a species is spread out. So in the Galapagos Islands, tortoises evolved differently depending on what island they were on. Birds evolved differently. Okay, all islands, they're all close together, but they all evolved differently because the islands had different food resources, right? So again, tortoises that had high food, they would have longer necks. Tortoises with more low-lying foods had those shorter necks that could get low to the ground. Okay, so that's how we see evolution happening there in real time. Okay, I'm going to go ahead. We're just going to call it a day right here. We have one little bit left. We'll get to it tomorrow. I'm trying to keep this 15 minutes. I'll do my best. Again, sorry if I'm kind of going fast, guys. Just feel free to pause it, making sure, again, we're in the middle of lunch, and I'm just making sure I keep the lessons as short as I can make them, okay? But let's do a little quick, we'll get to a practice question tomorrow. We did one earlier, which I think you already saw before. Just as a reminder, again, students, we have the syllabus signatures due next Friday. We online, again, just print it, write it out, or just rewrite the signature lines with the syllabus title. That's fine with me as long as I can definitely tell it's your signature and then your parents. And make sure I know whose it is, not just signatures, any, know it's from you. And Also, we have the Facebook activity. You just need to type it and submit it. That's going to be due this Friday. And we have the syllabus quiz due this week as well. So get on that. Get up to it. We'll finish this tomorrow, and then we'll also talk about homologous structures and vestigial structures with more videos tomorrow. Again, students, have a wonderful day. If you have any further questions, feel free to message me on Canvas, and I will, or call my Google Voice number, and I will try to get back to you within 24 hours. This is Mr. Campbell. Have a wonderful day. Take care. Signing out. And just trying to find the end record button here.